Hello and welcome to a guide on how to use task runners with AWS. During this guide, I'm going to walk you through how you can set up all of the stuff you need inside of the AWS console, as well as how you can automate this with Terraform. Now, let's jump in to begin with AWS and get started. Jumping into AWS, we're going to need to create a number of roles and policies in order to make this work. So let's jump into the IAM page and make those. Once we're on the IAM page, we want to go over to roles and we're going to create a brand new role. Next, we're going to select custom trust policy. And in here, we're presented with a JSON that will set up the policy for us. Now, there is one in the documentation that is linked below that you can use to paste in here. Here, I've pasted this one in, which uses the ECS tasks service. Once we've done that, we can now press next. For this role, we are going to need to add one policy permission, which we can easily search for by putting Amazon ECS, and we're going to give it the ECS task execution role. So let's make sure to select that. Now we need to give this role a meaningful name. I'd recommend calling this the ECS task execution role, and we're going to create a separate role which has a similar name too. And we can see that the trust policy is correct and that it's got that added permission too. So once we've done that, we can press create. Once that role has been created, what we can do now is create our second role, which is the ECS task role. Before we do that though, we should click on view role and we should copy the ARM. We're going to need that inside of Kestra. So copy that and get the example from our documentation, and we're going to add them into the variables at the top. So this is the execution role ARM, and I'm going to simply just paste that in like so. Next, we want to make the task role and get the ARM for that. So let's do that now. This role is going to need to have S3 access. So first we need to create a policy for it. So let's go to policies and click create policy. Now that we've selected create policy, we want to go to the policy editor, select JSON, and then paste in the pre-made example inside of the documentation. This has the 4 permissions that we're going to need for S3. So once we've done that, we can scroll down and select next. Now we need to come up with a name for this policy. I'd recommend naming it something sensible. Because this is for the ECS task role, I'm going to call it the ECS task role S3 policy. Now that I've done that, we can create the policy and now make our ECS task role. Going back to roles, we can then go do exactly what we just did, custom trust policy. Again, we have a trust policy in the documentation that you can paste in. Once we've done this, we're going to click next, and we are going to add a permission. So let's search for that permission that we just created. And in fact, we can see it right there. So let's click the little add button there. Then we can press next. And again, let's name the role something sensible. This is for our task role. So ECS task role would be best. Once we've done that, we can go down and see that it's got the role that we want to have. And then we can click create role to create it all created. Perfect. So we've now got our 2 roles. Here we're going to want to be able to, again, copy that ARM so we can then put that into Kestra. So let's just change that and get that updated. Now we've done that, now we can create the batch part for actually creating our task runners. To do that, we're going to search for batch in the search and go to batch as the under services. Now that we've done that, we need to create a number of things here. I recommend just adding first run in after a hash in the URL, as this will then help us set it up from scratch. So you should be presented with a screen like this, and we can press get started to jump in. For this, I'm going to recommend using Fargate. We can then press next, and this is where we can name our compute environment, which if you saw earlier is actually one of the variables that we're going to need in a minute. So let's name this something sensible. Now that I've named that, I can scroll down past all the defaults and then select next. And then I need to create a job queue as well, which again is one of the things we're going to need in a minute. So I'd recommend naming this fairly similarly to what you named your compute environment. And once we've done that, we can then press next. Now we're on the job definition. Again, I'd recommend naming this similar to the last one. So I'm just going to put job definition on the end. And once we've done that, we need to then scroll down and select our execution role, which we just created. We can also update the container image here. I'm just going to use one of the Kestra PyData ones. And after we've done that, we can then create our compute environment. I'd also recommend adding a container image here. This is using the PyData one that's got a bunch of the Python libraries that we might want to use built in, so that our task runner is going to run off of that. Once we've done that, we can then create our job. Again, I'm going to use a similar naming format for that job, and then I can press next. And here we can review everything and double check that it's all correct. So we've got the name of our compute environment. We can also scroll down and see that job queue as well. we can also see that the job definition is set up with the correct task execution role that we made. And we can also see that we've got the container image and the job as well. Now let's create this, and then we can get the ARMs that we're going to need inside of Kestra. Now this might take a couple of minutes to create, but once this is done, then we can get the last couple of bits we need to put them into Kestra. Wonderful, that didn't take very long. So now we can go to our dashboard and we can see the compute environment is here, as well as the job queue. Now, if I click on that compute environment, we can get the ARM, which we're gonna need, and then we can go back to Kestra and update that value again. We're gonna wanna do the same with the job queue. So let's go back to AWS Batch, click on job queues, and we can see the one that we just created is there. When we click on that, we can get that ARM and we can paste that in too. So now everything should be up to date and using the correct values. And we can actually scroll down to the task runner properties and see that we've got the region configured, we've got our access key and secret key, which we can talk about in a minute. The compute environment, job queue, execution role, and the task role all exist. But the one thing we haven't done is create a bucket. And so the bucket is going to be really important. Again, similar to the previous guides we did with Azure and Google Cloud, we need some sort of bucket to be able to store the files that we're going to be executing in the task runner. So let's do that now. All we need to do is search for S3. Once we go to S3, we can just create a bucket and just keep everything to default and just call this something simple. I'm going to use a similar naming format to earlier. We can scroll down and then click create bucket. And we can just wait a few minutes for this to create, and we will then get the name of our bucket, which is just here. Copy that and paste that into Kestra, and now we should be ready to go. Now to get those AWS access key and secret key, you can find that under security credentials in the menu. Now that we've got everything set up inside of Kestra, we can head over to the job queues here, and then jobs, and then we can select the job queue. And what we can do now is press execute and see this unfold in front of us. And as we can see here, it is submitted the job successfully to AWS. And if I refresh this page and then select the queue, we will see that it is successfully starting the new job. And we can see the status, if it fails or if it's successful. So this will probably take about a minute, and then we'll be able to see the data from it. And as we can see here, it has successfully executed the Python script, giving us some information about the environment that the task runner is running on. And if we head over to AWS and click refresh, we'll see that it is now successfully running the task as well. So once this is finished, we'll see that it will say successful in the AWS console, and Kestra will also say successful, which is what we want to see. Just like that, Kestra is now successful, which is just what we want to see. And if we go and refresh AWS, we can see that that was successful as well. So that gives you a quick overview on how to run tasks on AWS Batch. Now, separate to setting it all up in the AWS console, as great as that is, it's a bit annoying that every time you want to use a task runner, you have to get all of that configuration. Well, that's where Terraform comes in to make things a little bit easier. Here, we can easily use Terraform to set up AWS for us and then pass over those ARMs directly to the task runner. So here, what we've got is a task that is going to use Terraform, and then we're going to just pass in the region and bucket that we want it to use. And then it's going to just generate all of the resources we need with Terraform, generate a file that's then going to be passed over to Python, and then Python will generate that in a format that we can then hand over to our task runner. So here we can easily see that the task runner has got all of those values that we had as variables earlier, but just as outputs from a previous task. And then, yeah, we can just use this across multiple different tasks. So let's give this a go and see this in action. And as we can see here, it's going to clone the Terraform deployment repository that we have already made, and then it's going to start initializing everything with Terraform. As we can see here, Terraform has successfully generated all of the information that we need. It has left a warning because some of it already existed, but it allows it to then hand it over. And as we can see here, the Python script has passed that information from Terraform into a format that then our Python tasks can execute. So here we can see the first one has successfully executed, and we've got another one here that is in the process of executing as well. So Terraform just really is the cherry on top here of helping you just automate the whole process effortlessly. Hopefully you found that useful, and you're going to start using AWS Batch with Kestra to automate some of the tasks that require a little bit more compute power. I'd love to hear in the comments below how you're using AWS Batch to automate a number of your tasks onto remote compute environments. Don't forget to join our Slack community where you can ask questions there, and we'll be more than happy to help you get set up with task runners.